Hello and welcome to this video. In this video we're going to talk about powers of powers. While this might sound complicated, it might actually be easier than you think. Now before we get there, let's actually see what happens when I have a power of a product. And you guys remember what a product is, right? So a power of a product. Let's start a bit easy with 5a times 3. Well, if I write this out, this means that between brackets, so the whole 5a has to raise to the power 3. So each factor of the product is raised to the power 3, which actually means I can write it out like this. And while I might not be able to calculate what a to the power 3 is, I can calculate what 5 to the power 3 is. And 5 to the power 3 means 5 times 5, which is 25, times 5, which is 125, times a to the power 3. I don't have to write down a multiplication sign here, because there's a number and a letter. But this is how that actually works. Okay, so let's look at another one. If I have x times y to the power 5, how can I simplify this? How can I write this down without brackets? I have to take each factor of the product and raise it to the power 5. Now, we learned earlier that you can actually add the exponents if you multiply powers, but when is the only time I can do that? If I have the same base. Well, the base here in this case is x, and the base here is y. So those are not the same base, so I can't actually add the two exponents. However, because I am working with letters, I can write it down without multiplication signs. So I write down this. Okay, let's just do one more. What if I have minus 3p to the power 4? Try and work this out. Now again, I have to take each factor and raise it to the power 4. However, because I have a negative number here that's in between brackets, I have to write it out between brackets as well. So each factor of the product raised to the power in this case. Okay, so what is minus 3 to the power 4 between brackets? What does that mean? Well, minus 3 raised to the power 4 means minus 3 times minus 3 times minus 3 times minus 3. Now I have an even times of multiplying negative number, which means I get a positive number. Because if I multiply this, I get a positive number. If I then multiply it with a negative number, I get a negative number. And if I multiply it with another negative number, I get a positive number. So if you have an even amount of negative numbers which you multiply, you get a positive number. 81. Okay. So I have 81 times p to the power 4, and I can just write it like this. This is how you simplify it. Okay, so that's when we have a product raised to the power. What if we have actually a power of a power? So let's say we have a to the power 3 raised to the power 4. Now what does this actually mean? What it actually says is a to the power 3 times a to the power 3 times a to the power 3 times a to the power 3. Because if we look at the exponent, then the a to the power 3 is the base number, and the 4 is the exponent, which tells us how many times the base is going to get multiplied by itself. And in this case, it's 4 times. So I can write it all out, and you would get something like this. Now I can count the a's, 12. So I multiplied a with itself, So the base is a with itself 12 times. And I get the same thing here. I can do a, which is a to the power 12. Now if we look at this again, if we look at the a to the power 3 raised to the power 4, we can actually see that if we multiply the exponents, so if we multiply the 3 with the 4, we get 12, which is the exact same number I got here. And this is actually kind of logical, because if you look at this example again, we see that we add 3 4 times. So this means that if you have something of a power raised to a power, you multiply the exponents. Okay, let's do an example. Let's say I have 2p raised to the power 4, and the whole thing is raised to the power 3. Now remember, if I have something between brackets, I have to raise it to the power 4, then I have to raise all the factors to that power. Okay, so let's try this out. So factor 2 raised to the power 3 times, I'm going to put it between brackets, p to the power 4 raised to the power 3. 2 to the power 3 is 2 times 2 times 2, which is 8. And p to the power 4 raised to the power 3 means I have to multiply the two exponents, which gets me 12 in this case again, which means I have p to the power 12. Now I can just leave the multiplication sign out, and this is my answer. Let's try another one. I have minus x times y raised to the power 4 raised to the power 4. Try and solve this one. Okay, so each factor is going to get raised to the power 4. We have a factor minus x raised to the power 4, and we have a factor y raised to the power 4 raised to the power 4. And I'm going to write this out for you guys. So let's see, the minus x actually means minus 1 times x. So if I have minus 1 times x and I raise it to a power 4, I can again write down the factors. Well, minus 1 times minus 1 times minus 1 times minus 1, 4 times minus 1 means 1. And x to the power 4, I can just write down like this. And I can leave out the 1, so I get x to the power 4. Was already a bit tricky, right? Okay, let's do the y to the power 4 to the power 4. Now, I've learned that if I have a power of a power, I can just multiply the exponents. So what I get is x raised to the power 4 times 4, which is 16. If I write this all out, and if I multiply this x to the power 4 and y to the power 16, I can leave out the multiplication sign, put it in alphabetical order, and this is what I get. Now I'm gonna do one more example. Okay, so this looks a bit complicated, right? First thing we have to do is brackets. Get rid of all the brackets. I have brackets here. I have brackets here. I have brackets here. And I have brackets here. Oh, and of course I have brackets here. Okay, so from left to right, let's look at the first one. I have 5 times a to the power 3 to the power 4. So what we have is 625a raised to the power 12. Let's see how we can solve this. Well, first things first, we have something inside the brackets, a to the power 9. We multiply that with 18, but a to the power 9 is also raised to the power 2. Now, remember, the first thing is get rid of the brackets. Then after that, we get powers, exponents, and then we get multiplication. So first we have to do the power, 18a. 18, because I can't simplify this any further. And this actually looks kind of the same as the one before. You see here, you see a single a to the power to a different power, like this. And we have a multiplication with something before the brackets. So I'm just going to do the same trick here. I'm going to multiply the 2 with the 3, which means 6. So I have minus 7 times a to the power 6. Okay, then there's a times here. So times minus 8a to the power 12. Last one, we have minus 9a raised to the power 9 to the power 2. So we have 81a to the power. We even did all the powers that we could do because we can't do any more powers. So that means we have to move on to multiplications. Okay, so let's do the first multiplication. I have 625a to the power 12 times minus 3a to the power 2 minus 1875 a raised to the power 14. Okay, now immediately after this one there's another multiplication. So what happens, following the rules of the order of operation, is that I have to multiply my answer I just got with 2a raised to the power 4. This gives me minus 3,750. And then I have the last multiplication, which is minus 7, remember the minus, times minus 812, because this minus belongs to this 7a raised to the power 6. It gives me plus 56a18. Because this is a positive number, I have to add it. Okay, so then I got rid of all the multiplications. I just have to do subtraction and addition from left to right. So these are all like terms. Now remember, if this had been a to the power 16, it wouldn't have been a like term to all of these. The letter and the exponent has to be the exact same. Okay, so what happens if I add and subtract all these from left to right? What's my final answer? Well, my final answer is minus 6,928a to the power 18. Now, this looked like a lot of work, and it was, but you were able to do, but we are able to do this. So practice a lot, and I will see you next time. I wish you a very good day.